morning. So today we are going to talk about evaluating algebraic expressions. We're going to continue with our notes from the other day where we titled them 3.1 algebraic expressions. So you can open those up. Anything with a star that I have in this video, I would like you to either pause the video if you need to, or just make sure you have it written in your notes. An algebraic expression is an expression that may contain numbers, operations, and one or more symbols. Parts of the algebraic expression are called terms. I'm going to change this color one. All right, so let's take a look at some of our examples here. I know you have an example written down from the other day. If you'd like to add a new one, that would be a great idea. A symbol that represents one or more numbers is called a variable. I know we labeled it the other day, but if you could add the definition, that would be excellent. Remember, this notebook is something that you can use on your quizzes in the future. The numerical factor of a term that contains a variable is called a coefficient. So this 5 is the coefficient because it's being multiplied by a variable. A term without a variable is called a constant. So 4 doesn't have a variable being multiplied to it, so it is called a constant. Again, go ahead and pause this video if you do not have these notes in your notebook yet. All right. So for these two examples, we're going to identify the terms, coefficients, and constants in each expression. So if we think back to what a term is, it's the part of the algebraic expression. Generally, it's separated by an addition sign. So I have two terms here, 5x and 13, and I will separate these with a comma. My coefficient is going to be the numerical factor of a term because it contains a variable. So 5 is my coefficient, and 13 is my constant because it is a term without a variable. When looking at this next example, I have three terms. I have the term 2z squared, y, which is really 1y, because 1 times anything is whatever that value is, and 3. And I'm going to separate my terms with a comma. My coefficients in this problem, and yes, I said coefficients plural, the first one is going to be 2, because that is a factor, a numerical factor that contains a variable, as well as 1. Because just because the variable looks like it's standing by itself, it's always being multiplied by 1 if there's no other coefficient. Then, last but not least, my constant is the number 3. So go ahead and include these two examples in your notebook if you don't have them already. Okay, so now we're going to write each expression using exponents. So I see that I have a variable d, d times d times d times d. And in case I don't know where to start, I'm just going to use a number to represent the letter. So let's start with d being equivalent to 2. So if I were to write out 2 times 2 times 2 times 2, I need to think about how I would write that using exponents. And I know that 2 would be my base and 4 would be my exponent, since 2 is being used as a factor that many times. Now, I do not know that d equals 2. So for now, I'm going to use d as my base because that's the number I see. And I see it 4 times, so that's going to be my exponent. Here I have another example. 1.5 times h times h times h. I know that h is being used as a factor 3 times. So the exponent is going to be 3. And I'm going to multiply that still by 1.5. Now remember, the exponent is being applied to the variable, not to the 1.5, so I can't simplify this expression anymore. Okay, so we are going to talk about evaluating algebraic expressions. So To evaluate an algebraic expression, substitute a number for each variable. Then use the order of operations to find the value of the numerical expression. Go ahead and pause the video to make sure that you have this in your notes if you need it. Alright, so here's an example of what I'm talking about when evaluating algebraic expressions. Let's evaluate k plus 10 when k equals 25. So some of you started this when you were practicing on the C77 worksheet the other day, but if you did not, I will walk through some examples. So k is going to take, or 25 is going to take the place of k, so you can see that with our red writing, we've just replaced the variable. So by replacing k with the number 25, I can actually add 25 plus 10 to get my answer of 35. Continue down to the next example. Now we're going to evaluate 4 times n when n equals 12. So first off, I'm going to write 4 times n, and I'm going to show you that it's the same thing as 4n. When you have a number next to a letter, it means the same thing as multiplication. So I need to either write 4 times 12, because that's what n equals, or I need to write 4 and then put the number 12 in parentheses, implying that I'm multiplying. And I know that 4 times 12 equals 48. So 4 times 12 equals 48, which is my final answer. All right, so here, this one's going to get a little tricky because we have 2 variables separated by a division sign. So A is going to equal 16, and B is going to equal 2/3. And since we know how to divide fractions, we should be able to plug 16 in for A and 2/3 in for B, and then solve 16 divided by 2/3. Now, going back to what I remember, I need to multiply by the reciprocal. And then I would plug in, or I would multiply 16 times 3/2. And I know that whenever I have a whole number, I need to write it as 16 over 1. And 16 times 3 is 48. And 1 times 2 is 2. And I know that 48 divided by 2 is 24. All right. The importance of this example is not only that we're using 2 operations, because we're using multiplication as well as subtraction, but I want you to see that they're replacing the x with a 5, and by doing so, they put it in parentheses, as you see here. That just means 3 times 5. So, to backtrack, 3x minus 14, we're going to evaluate that one using x equals 5. So I'm going to replace x with the number 5, and knowing that I need to use the order of operations, I'm going to multiply first, and then subtract 14, and end up with my answer of 1. All right, so let's go ahead and try and solve this problem. Evaluate z squared plus 8½ when z equals 2. So since z equals 2, I am going to plug in 2 for that letter, keeping my exponent, and then adding 8½. As I walk through this problem, I know that 2 squared is 2 times 2, or 4, and then I can add 8½. And it's kind of like doing my same shelf method as with the order of operations now that I've plugged in my letters. So now this is my final step. 4 plus 8½ is 12½, and that is my final answer. All right, so I have some examples for you to try on your own, just like we would normally in class, and then I'll check in with you on how you do. I am going to work these problems out eventually so you can check your answers. So first of all, I want to write the expression using exponents. So I see the letter J, and so that's going to be my base. And I'm going to see how many times it's a factor, and that would be 6. So J to the 6th power. Now over here, I'm going to start with 9 because I know I can't simplify that. And I'm going to multiply it by k to the 5th power. I could also write this as 9k to the 5th power because a letter next to a number means to multiply. Now we're going to evaluate these two problems here. Evaluate 24 plus c when c equals 9. So the nice thing about a smartboard is I can just totally override that c and replace it with the 9, which is its value. And I know that 24 plus 9 is 33. All right, so number 7, I have d minus 17 when d equals 30. So I can just replace the d with 30, and I can do my subtraction, knowing that 30 minus 17 is 13. So as you can see, it's not the math that's necessarily hard. It's remembering your skills about the order of operations and replacing letters, which are variables, with numerical values. All right, a couple more examples here. We're going to evaluate the expression when p equals 24 and q equals 8. So I'm going to write this on the side. I know that p equals 24, and I know that I need to divide and q equals 8. When using our math facts, we know that 24 divided by 8 is 3. So I'd like you to go ahead and try 9, 10, and 11, and I will ask you for your answers for you to submit into the form. And finally, we have a couple of examples where we have two operations. So I know that y equals 6 in these examples, so I am going to replace my y with the number 6. And knowing my order of operations, I need to multiply first. 5 times 6 is 30, plus 1. And then I can finish out that problem to get 31. I'll start you off on number 13. I know that 30 minus 24 are things that we know, and I don't want to solve that yet in case I need to do the order of operations. So I'm just going to focus on plugging in the variable first. Okay, and I know that y equals 6. So now when I look back at this problem, I know, according to the order of operations, I need to divide first. So I'm going to divide 24 divided by 6, and that's going to get me 4. And I'm going to let the rest of my problem fall down and solve. So go ahead and try these next 3 out on your own. And when you're done, you can move on to the next task. And please refer to this video if you need it tonight when you are doing your homework. Thanks. Have a great day.